Welcome. Today's lesson is on finding the distance and the midpoint of items. For example, if I have a number line, and on this number line I'm given an endpoint at -6 and an endpoint at 9. I want to find the midpoint for this line segment. To find that, the midpoint means halfway between the two. That's the average. So I'm going to average these 2 points together. So I'm going to add -6 plus +9, then divide by 2. I clean up the double positives and the double signs, and I get -6 plus 9 over 2, which is equal to 3 over 2, or 1.5. Therefore, the midpoint of this segment is approximately right here at 1.5. To find the distance between these 2 points, distance is always positive, it is never negative. I need to take the absolute value of the sum of the difference of these. So I start with this one and I subtract this. So I have -6 minus a +9, the absolute value. Clean up the double signs, which gives me -6 minus 9. The absolute value is equal to the absolute value of -15. But since distance is never negative, we take the absolute value, and the absolute value of -15 is 15. This is how you find the distance between 2 points on a number line. If you are given 2 points on a coordinate plane and asked to find the midpoint and or the distance, this is how you would do it. I want to first find the midpoint between these 2 points. Point A is at -4, 1. Point B is at -4, 5. I want to find the midpoint, the halfway point between these x's and y's. To do that, I find the average of the x's and the average of the y's. That's x sub 1 plus x sub 2 divided by 2. That's the average of the x's. And I'm also going to find the average of the y's. Y sub 1 plus y sub 2 divided by 2. X sub 1 is -4 plus x sub 2, -4 divided by 2. X sub 1 is 5 plus y sub 2, 1. Add these together. I get -8 over 2, +6 over 2. Simplify. My midpoint, the one in blue over here, is the coordinate where x is -4 and y is 3. To find the distance, I use the distance formula, which we learned in the previous lesson. Distance is equal to the square root of the differences of the x's squared plus the differences of the y's squared. So x sub 2 is this, -4 minus x sub 1, which is a -4, the quantity squared. Substitute y sub 2, 5, minus y sub 1, +1. Take care of the double signs. So this is -4 plus 4, which is 0. This turns out to be 5 minus 1, which is 4. Clean it up. 0 squared is 0, 4 squared is 16. Add them together, I get 16. But I still need to take the square root of 16, which is 4. So the distance between these 2 points is 4. And that makes a lot of sense, because the distance from this midpoint to here is 2. And from here to here is 2, so the total is 4. It's half the distance between the points is the midpoint. On a coordinate plane, here's another example. Instead of a vertical line or a horizontal line, we have a diagonal or an oblique. To find the midpoint, the average of the x's and the average of the y's. So I add my 2 x's together, divide by 2. I add my 2 y's together and divide by 2. So -2 plus 2 is 0 over 2. Minus 3 plus 2 is negative 1 over 2. Simplify. The coordinate for this midpoint is where x is 0, y is negative 1/2. To find the distance, I use the distance formula as previously stated. The difference of the x's squared plus the difference of the y's squared, the square root of that. Substitute what I know. X sub 2 is negative 2. X sub 1 is positive 2. So I find the difference of that. Y sub 2 is negative 3. Y sub 1 is positive 2. Take care of the double signs. This becomes negative 4, the quantity squared. This becomes negative 5, the quantity squared. It's important that you keep your parentheses here. If you don't use your parentheses properly, you will get garbage for an answer. So now we know that negative 4 times negative 4 is 16, and negative 5 times negative 5 is positive 25. Add those together, and I find out that the distance between these 2 points is the square root of 41. 41 is a little more than 6. That's the perfect square of 6 is 36. And the square of 7 is 49, so this is about halfway between. So it's about 6.5, 6.6, 6.5, 6.6, roughly. To find the distance of a missing leg on the Pythagorean theorem, I want to find that. If I have a right triangle, and I'm given a hypotenuse, that's the C, and I'm given one of the legs, I want to find the missing leg. How do I do it? Well, I substituted the Pythagorean theorem. The sum of the squares of the legs of the legs is equal to the square of the hypotenuse. I always enter my hypotenuse first. If I do that, which is the longest side, and it's the side opposite the right angle, if I do that, I rarely make a mistake in entry. So if I enter the hypotenuse first, I get this. I enter this for A, and I'm looking for B. Simplify. 16 plus b squared is equal to 41, because the square root of 41 squared is 41. Simplify. To move the positive 16, I have to do the opposite, so I subtract 16 from both sides. I'm left with b squared is equal to 25. Therefore, b is 5. The distance from here to here is 5. Please go to Edmodo, find lesson 1.81, and complete the check for understanding.